All right, cumulative review 3, problem 27. So the first thing I want to do to simplify these, we're multiplying rationals, multiplying rationals, dividing rationals. I want to factor everything. This doesn't need to be factored. This one does. We factor through AC factoring. And so that's how we got this. Now at this point, I want to start canceling anything out that matches on the top and on the bottom. All right, x plus 1's matched up. We cross those out, and we're left with what remains. I decided to just put the 5 in front of that expression. Right. Problem 28. Remember that you have to flip the second fraction. It's always got to be the second fraction. Flip it upside down or the reciprocal, and then change this to multiplication. All right, so we flipped that. I did factor it at the same time. I factored this after I flipped it. And so this was just GCF factoring. Excuse me. Same with this one here, which they're both the same expression. And then because they matched up, I canceled them out. Okay, I did change this to multiplication too, sorry. So I flipped the second fraction, factored it, changed to multiplication. Cancel these because they match up. All right, and then I just write down what remains. Nothing else simplified. Problem 29. All right, simplify the expression. Nothing factored out, didn't need to do that. So what we're doing here is addition. And so what we want to do, when you add or subtract fractions, you want to make sure that you have a common denominator. So that's what I was doing right out of the gate, was trying to come up with a common denominator here. And so how do I get this to match that? Well, in order for a 2 to match an 8, I got to multiply it by 4. All right. I didn't need to multiply by 4xy. This already has the xy. That's the denominator that needs the xy. So this gets multiplied by 4 over 4, because whatever you multiply, whatever you do, you got to multiply to the top and the bottom. All right, and then this multiplies by xy over xy. So I distribute the 4 on top. 4 times 5x, 4 times 2y. That's how we get this expression. And then the 4 on bottom, 4 times 2 is 8 with the xy. Over here, 3 times xy, 8 times xy. And then because we have common denominators, we can just go ahead and add up the top, which there are no like terms, so you just add the whole thing straight across. Just write it all out basically and put it over that one denominator. Number 30. Because we have an equation now, notice this was an expression, no equal sign. This is an equation. That's where we want to go ahead and, if it were just 2 rationals, like this one here, 1 rational, 2 rational, we could just cross multiply. But because we have a third rational, 1, 2, 3, we want to go ahead and find that least common denominator. So I decided to take the 6 and put it over 1. And so I'm looking at denominators of 1, x, and 3x. I look for the largest, 3x. And I say, can I multiply something to a 1 that could make it become a 3x? Well, sure, I could multiply this to 3x. Could I multiply something to x to make it become a 3x? Well, sure, I could multiply just to 3. Cool. Then that means that this is my least common denominator. That's what I want to multiply to both sides, the left-hand side and the right-hand side. Okay? So when I multiply to the left, take a look at this denominator. Is anything going to cancel out? Does anything match up? No. So just multiply the whole thing. 3x times 6, 18x. The next one. Does anything match up with this denominator? Well, yeah, the x does. So I will, in my mind, I will cancel out the x and only distribute the 3. 3 times 1 is 3. On the right-hand side, does anything match up with this denominator? Yeah, the whole thing does, the 3x and the 3x. So I don't need to distribute anything. I just simply write the 39. And now I have an equation. I solve the equation and get an answer of 2. But I want to check. I didn't write that down, but I do want to check to make sure that it's not going to cause me to have a 0 as a denominator. So if I plugged it in a 2 here, would it cause me to have a 0 as a denominator? Nope. If I plugged a 2 in here, would it cause me to have a 0 as a denominator? Nope. Good. Then that means 2 is correct. 31. Because it's only 2 rationals, you could cross multiply. X times x plus 2. X times x minus 6. Distribute. We get this. start solving, and when I subtract the x squared to both sides, it ends up canceling both of them out. So we're left with this. And when I go to add that to the other side, well, I notice that all I get is 0. Yes, the x equals 0, but does it cause us to have a denominator of 0 when I plug it in? No, because 0 minus 6 is negative 6. 0 plus 2 is positive 2. So that is the correct answer. For this one, finding the vertical asymptote and finding the holes. Holes only occurs if you have expressions that cancel out. See, when I factor this using dots, difference of two perfect squares, I get this expression. Factor this by AC factoring, and we get this. We did have a match and something canceled. That means we do have a hole. Set that expression equal to 0 and solve. That's the x value of the hole. Plug that value back into the simplified expression, this one. And that's going to give you your y value. So plug in a 3 here and here. 3 plus 3 is, I don't know why I wrote 9, silly me. All right, 3 plus 3 is 6. And 3 plus 7 is 10. That does simplify. All right, simplifies to 3 over 5. All right. And then the vertical asymptote, that's the one that did not cancel that denominator. Set equal to 0 and solve, and there's your vertical asymptote.